Oh, hi, everybody. My name is Matt Storrs, and welcome to Mattsplaining. On today's episode, we have somebody talking about something scientific that they are an expert in. Expert, please introduce yourself and tell us what you're an expert in.
Yeah, I'm Ben Miller. I'm an expert in microscopy, and today in particular, we're going to be talking about scanning electron microscopes.
Excellent. I don't feel like I know the most about scanning electron microscopes, but I feel like I know a bit, mostly because of the movie What the Bleep Do We Know? And the water experiment within that film. If you're familiar, basically a scientist in this deceptively documentary, maybe fiction movie. They didn't really, it's 2004, so it was a time of what was truth. And this scientist took water, froze it, and then went and looked at the water under microscopes. And based on people saying nice things or mean things to it, the water molecules would change shape. And then we're mostly comprised of water. So just saying thank you to somebody could completely change their molecular buildup and how they work, so long as their body is completely frozen. And so that's my main background to microscopes from around that time. And I think it also is difficult because at the time of that movie coming out, I was in high school and we were using microscopes at the time. I don't think it was necessarily scanning electron microscopes, probably something a little bit more simple. And I had a problem pretty consistently with the slides of our microscopes, depending upon what we were looking at, samples of blood or water or whatever we were looking at. I would rotate the microscope down too far and I would crack the slide. And then we would look at it, like you would hear a little bit of a crack, but you'd be distracted. You're a teenage boy. And then you look through it and you're like, oh, that's really interesting. There's in this sample of blood, there's this large crack going down the middle of it. I wonder what that means. And doing an analysis and doing your write-up about these things and being like, oh, and then the biology teacher coming in and being like, yeah, you need to stop. You are breaking so many slides. And I think around that time is when I got exposed to the lens black market in the scientific community. I don't know if you're familiar with this. Basically, my teacher had lenses and the slides, and they were getting them, as a teacher you would think like, oh, they don't have the most funding. And so they actually had a side business where they did DNA analysis for local businesses and mostly like police and stuff like that. And they used the money that they made from that to go to the scientific black market where they would get their slides and get the lenses for microscopes and scientific experiments that they were doing to put out as much, basically some for the kids, obviously the less high quality ones for the kids, but then for their personal experiments, which we are not completely clear of what they were doing, they would retain that. And it's my understanding that that's become more and more pervasive as the decades have gone on since then. And that now a lot of the scientific community is really dependent on this lens and scientific black market. So a lot of like the microscope lenses that you might see in a regular microscope, 10 to 50% of the lenses were developed on the black market, the scientific black market. As well as that, in that biology class, this kind of is going to a side, this just might be discussion. I believe these microscopes need to have a fairly sanitized environment, maybe not completely sterile environment, but it needs to be fairly clean. And then in that environment in high school, and also frankly, when I did use them in college, because I do remember using them a bit in college in one of my labs. Interesting. Yeah, there were always animals in the classrooms and the labs. Like in my biology class, there was an iguana, which I guess is not necessarily something that like is getting hair everywhere or anything. I mean, it's shedding occasionally, but in college, there was a lab cat and like it would occasionally jump up, and like they put it away when like we were using Bunsen burners and stuff like that, but it just seems like that would be inherently dangerous. So I don't know if that's like a common thing in the scientific community to like have a lab cat or lab animal. I mean, I guess they would have lab animals if they're like testing on like mice and stuff like that,
Yeah.
but I think you're not supposed to like form a relationship. Also, that would be kind of mean to the cat if like you did also have lab mice. Like you're playing with fire there. If the cat learns how to like open up those containers, then it's just getting those mice. You're going to mess up experiments. So based on what you've heard, about how much of that would you say was accurate?
Well, you told me a lot of your personal experiences,
Okay.
so
Okay.
I'm hesitant to deny that any of these things happened to you. Like you certainly did see the 2004 movie What the Bleep Do We Know? As far as I understand it, none of that is accurate.
Right.
But
That
it's
was
a pretty famous falsified study.
Mhm.
But you did see it, so I don't know what the level of accuracy is for me to grade it on. I've never heard of the lens black market. It sounds
Okay.
like your high school teacher was very entrepreneurial.
I just always think that there's going to be a black market related to science, and I just hope that there is one.
Yeah, I mean, potentially there is, but most labs, I mean, like you apply for grants for
Okay.
funding, and these grants are like extremely generous, and you're applying to like buy the equipment at
I see.
very exorbitant prices because you're using government money.
Okay, so it's
Um,
more less of a black market and more of like a government grant system. Okay.
yeah. I mean, maybe if the lab like isn't doing super well or hasn't gotten a lot of grants, I mean, you might get something used or something like that, or you might try to like go into another lab in the institution and try to use some of their equipment. But usually it's yeah, and potentially there is some black market that I haven't been aware of because I'm just such an innocent boy, but I've never personally encountered it.
Okay. I mean, once you get into the distribution and figuring out the purchasing, let us know, because if it is there, people deserve to know.
Oh, absolutely. Yeah. You'll be getting a good cut of the money.
Oh wow. Well,
Um,
all right. Sounds good to me.
so at no point did you even begin to describe a scanning electron microscope. So I think in that
Yeah.
respect, you did happen to fail.
Okay.
But it was
Okay.
very interesting. I very much enjoyed hearing about your personal experiences, about you cracking the slides and stuff. I've
Yeah.
definitely made mistakes with even more expensive
Hmm.
microscopes because generally they'll the nicer ones will have like electronic stages. I mean, I enjoy like the fine tuning of like manually touching all the knobs and stuff,
Hmm.
but a lot of them have like electronic stages that will naturally just stop at certain points that they're not hitting into the sample. Although one time, like after an internship, like freshman year in college, we were sort of like putting something on top of the slides, like another apparatus, and then using an electronic stage. And I set the coordinates really wrong on it and fully destroyed this stage that was worth like
Oh
$20,000.
no.
Yeah, and I was petrified to tell the professor what had happened.
Yeah.
And luckily, they were pretty chill about it, but it was a little bit more than just like a glass slide that's worth 10 cents, a dollar max. Like,
Hmm.
oh, but so it's a scanning electron microscope. Sorry,
Yeah.
that's why we're here. So the difference between a scanning electron microscope and a typical microscope is what it's using to image the sample. With the typical
Okay.
microscope that you're using in high school labs, it's called like a light microscope. It's
Hmm.
using light to image the sample.
Okay.
And so light is generally the size of light is the wavelengths between like 400 and 700 nanometers. That is
Hmm.
the size of light. And because of the size of light, it gives a certain limit to the resolution with which you can see things.
Okay.
So generally, the best resolution you could get with light is about 200 nanometers, and that's the smallest thing that you could possibly resolve. Because it's sort of like, I mean, like you can grab like a lot of small fine things with your fingers, but then
Mhm.
if you put on like mittens, it becomes difficult to grab things because you
Right.
don't have the same like fine articulation
You don't have that same sort of dexterity.
Yeah, so sort of similarly, like electrons are much smaller than light, so you're able to image smaller things using a scanning electron microscope. And it's nice to see small things and more details and such. And so you were right when you sort of touched on like the sanitized environment of the lab. Generally, there aren't any iguanas or cats running around. I don't know if it was like part bodega, part lab, or something like that.
Based on the college that I went to, it may have technically been a bodega.
Yeah, it sounds like there were a lot of side businesses going on.
It does, right? In hindsight, it really does.
Yeah, so an electron microscope is generally like a pretty sealed apparatus. At the top, there's something called an electron gun, which is typically a tungsten filament that is heated up, and it emits electrons. And the chamber of the whole microscope is in very high vacuum. Like essentially, you want to be taking out all of the air molecules, because that will get in the way of the beam of electrons.
That makes sense.
Yeah. So then there's a series of magnets, and the magnets sort of work similarly to, not exactly the same, but like somewhat similarly to lenses in a regular light microscope, where they're focusing the beam of electrons. Because the little tungsten filament, it's going to be spraying electrons everywhere.
Right. It's unfocused. It's like a shotgun as opposed to just an electron gun. It's more of like an electron shotgun.
Yeah, although if you look at like the fuse that holds the filament after the filament is burnt out, because eventually, I mean, you can get like a decent amount of life out of these filaments, but eventually they do like burn out. And so if you've ever replaced a filament, you'll see like on the base of the filament, there's some like discoloration from just like electrons being shot completely in the opposite direction as well. So it'd be a very bad shotgun if it shot some bullets forward and some back at you, and you're like, well, I guess I'm dead now.
Yeah, that wouldn't be the best design.
Fortunate.
Yeah, with the discoloration, what is the discoloration? Does it have, is it just kind of like a darker hue of the item, kind of like a stain?
Like if you've ever like spilled gas when you're like pumping your car, and then it's sort of like multicolored different layers, it looks sort of like that.
So kind of like iridescent in a way.
Yeah, exactly.
Very cool.
Yeah, so we've got the lenses to the magnets to focus them down. They're actually called condensers, might be the proper term for it. And then it forms this small beam of electrons that you scan over the sample, sort of like the old CRT monitors almost. And that's sort of how it forms an image by scanning over a certain area. And then there are a couple different collectors that you use to detect the image. That's the basic premise, and we can go a little bit deeper, or do you have questions at this point in time?
No, I mean, this has been very insightful. What's the most common instance where you'd be using one of these?
It just sort of depends on like what type of lab you're in and what sort of stuff you want to be doing. So I mean, there's certain labs where you might be using it every single day. There's certain labs where like maybe occasionally you've made like a sample and you want like a very particular image of like the morphology, like the shape of the sample at a very small scale for like a paper for publication. Yeah, so it just sort of depends like what sort of work you're doing. And you can image like all sorts of things. The easiest thing to image is something metal, because you generally need your sample to be conductive. Because it'll dissipate the electrons. Because if the sample is not conductive, what happens is something called charging. Like you're shooting a bunch of electrons at it, and the electrons build up on the surface of the sample and then start repelling the beam of electrons. The image gets all like fuzzy, and you can't really see it well. So for non-conductive samples, you do something called sputtering. Where you put like a thin coat of metal on it. Usually gold is the most common metal, and then you can image just about anything you want if you put a nice shiny gold coat on it.
That's fantastic. And where would they source their gold?
Just the internet. I mean, there's just like a
Okay.
series of websites where you can buy certain scientific supplies and
Okay.
equipment. No one's like going out and mining it themselves.
Okay.
So
Okay.
I'm not like very familiar with where they're getting the gold pellets from.
Okay. So, but yeah, so it's not necessarily like from 6 a.m. to 9 a.m. you go to the mine, get the gold, and then you go to the
Yeah,
lab.
they're not doing farm to table
Okay.
at these labs.
Okay.
We're just getting gold out of the can.
Yeah, gold out of the can. I mean, it's still good gold. Gold is gold, is what I say. If people wanted to learn more about microscopes in general, or they wanted to learn more about you and what you do,
Already done the 15 minutes. Wow.
I know it goes fast. It goes real fast. There's like, oh, hey, yeah, there's all this other information that I can provide about this thing. And it's like, yep, well, too bad. It's been 15 minutes. Yeah, if people wanted to learn more about you, learn more about microscopes, where might they be able to find some information about that?
I hate to give this answer, but Wikipedia is like a pretty good resource. Or if you just, yeah, I mean, if you search like Google, there are a lot of good websites out there. I don't think anybody's trying to deceive you about scanning electron microscopes.
Not yet. You don't know. Maybe the people in the black market are going to come in.
Yeah, as long as you're not trying to buy the microscopes,
Right.
I think if you just want to learn about them, the internet's like a pretty good resource. Come to shoot me a message on Instagram and we can chat about this more.
Cool.
I don't know if that's a weird thing to solicit, maybe not.
And do you have anything coming up where people might be able to see you?
Oh, thanks. Yeah. So I also do stand-up comedy. And so I have a show at Grove 34 in Astoria on Saturday, November 19th. It's called Stand Up Science. It's an hour of science jokes. I don't think at any point I talk about scanning electron microscopes. You're welcome to heckle me with questions about it.
Fantastic. Excellent. Well, thank you so much, Ben. I really appreciate you taking time out of your day to talk to me about this. And I hope you have a great rest of your day.
Oh, thanks so much. This is a lot of fun. I hope you learned something.
My name is Matt Storrs, and this has been Mattsplaining.